Hello all, this is Anusha. This is the second video of my cab booking analysis. For project introduction, objectives and data overview, please check my first video. The link is given in description. Now we start with the EDA of the project. Here I have loaded the data. We have around 2 crore 5 lakh records with 25 columns. I have dropped some columns by evaluating relevance to the problem statement by asking whether each column contributed meaningfully to the goal, by analyzing column distributions and impact, and found that some features were not aligned with the core objectives of the analysis. And dropping irrelevant columns reduced my data load and simplified the dataset, and that helped in focused and efficient analysis. Here I've checked the data types. Here I've checked the nulls, and we don't have any null values and we don't have any duplicate values. I have created a total congestion column with these columns, the congestion surcharge and the congestion fee. After creating that column, I have dropped these two columns to reduce the data load. I have created this column to identify peak congestion patterns and areas with heavy traffic, and also to identify how traffic related surcharges impact overall fare and trip efficiency. We have another column with license number, and if you check the distribution, 70% are of this license number and 30% are of this license number. As per data dictionary, for each license number we are given the service provider name. So I have replaced the license numbers with the service provider name because it would help for better readability and interpretation, and I have renamed that column, this license number column, as service provider. And next I have created another column called trip time with which is like drop off time subtracted by pickup time. Here I divided by 60 because I wanted it to show in minutes, which is better for interpretation. Now in numerical columns, I have categorized numerical columns based on primary attributes and secondary attributes. Primary attributes are those which are the core metrics which directly describe the trip, and these are the secondary attributes, and this is the statistics for all the numerical columns. As you can see the distribution, we see some outliers, some negative values, so we will go check each column. So I'll do the univariate analysis, which helps to understand the distribution of individual variables, to detect outliers and anomalies in single feature, and to identify potential data quality issues like missing, inconsistent or unrealistic values. So first we'll do the univariate analysis for primary attributes, that is the base passenger fare. So when I checked for the base passenger fare which is less than 0, because if the trip is conducted the fare can't be less than 0, so I filtered those and I filtered some outliers by giving using this percentile based outlier trimming. I have arrived on with this number by multiple trial and error, and then I felt this is appropriate for the analysis, and after removing outliers, it is 1% of data we are removing to filter out the outliers. After that, this is the box plot. Here we see the values. And after that, I have for the minimum base passenger fare also, I have kept the values for $1. And if I check the trips with base passenger fare less than $1 and do the mean, it is the trip time is almost 10 minutes and the trip fare is almost, distance is almost 2.8 kilometers, which is not realistic. So that is why I have filtered the trips which have base passenger fare less than 1. So after the removal of outliers and the extreme minimum values, this is the kind of distribution we get. Here we see a long tail, that is because in trip details, you would also have the long distance trip details also. Now we'll explore the trip miles, that is the distance column, and I have filtered out the trip distance which are 0 because if the trip has started, the distance can't be 0. So I have filtered few values. I've checked the percentage, and the percentage is very low, then only I am removing that column. So after that, I have removed the outliers by using this quantile method. I didn't use threshold. I tried giving I didn't use the typical IQR. I used quantile because and I've used trial and error to understand what is the better threshold according to the trip details. So after filtering the distance, here we get, and I have even filtered the lower values like the trip distance, which is 0.06 miles, which is almost 96 meters. So I thought the trip distance which is less than 100 meters is very unusual. So I have filtered few columns with respect to that value, and this is the final distribution we get. Again, we have tail values because the trip distance can be more. Next, we have a trip time column. So this is the distribution, and I have checked the box plot. As you can see, there are some outliers. So I have capped with this threshold 170. Again, I came with this number with lot of trial and errors. 170 minutes is approximately equal to 2.83 hours. So, and again for the lower limit trip time, I made minimum of 2 minutes. I tried calculating the distance mean for the trips which are less than 2 minutes, and it is almost a half kilometer. Which might be true, but then I have checked for the base passenger fare mean, and it is 8.7. So for the trip which is less than 2 minutes, $8.7 dollars pay is unusual. So I have filtered few rows with that value, and this is the final distribution we get. I have not removed all the long distance, long time trips, because trip time can be more because of the traffic congestion and as well as the distance. And then I have done univariate analysis for secondary attributes as well, like for the tolls. When I see the 13% of data or trips has toll amounts, and when I check with upper percentile, 75% is 6.94. So by giving the upper percentile, when I calculate the box plot, this is something like this. So I have not filtered any rows with respect to the secondary columns. We'll do it if it is needed. Next, for the airport fee, again airport fee, we have 7.8% of data which has airport fee, and this is the distribution we have. And for the tips also, I have almost 17.5% of data has tips also. So I have calculated the distribution. We have some really large trips. So I've calculated if there are any records with tips greater than base passenger fare, and we have 4,400 records. But when I checked their mean, it is almost $20. While these tips are larger than the base fare, they are not all extreme in amount. So I feel they are quite reasonable to keep. Then I go to the driver pay, and I see in the distribution we have some negative values. So the driver pay being negative in spite of the trip being conducted is unusual. So I have filtered out those records, and the upper limit also I have checked. So here also I have just removed the rows with negative values. Apart from that, I have not removed any records as of now. And for the total congestion column, this is the distribution we get. It is almost 40% of the data has congestion surcharge or congestion fee. So that's all for the univariate analysis of numerical columns as of now. In the coming video, we'll complete univariate analysis of the remaining columns. Thank you.